What I want to do in this video is give ourselves a basic introduction to the phenomenon of light. And light is, at least to me, it is mysterious. Because on one level, it really defines our reality. It's maybe the most defining characteristic of our reality. Everything we see, how we perceive reality, is based on light bouncing off of objects, or bending around objects, or diffracting around objects, and then being sensed by our eyes, and then sending signals into our brain that create models of the world we see around us. So it really is almost a defining characteristic of our reality. But at the same time, when you really go down to experiment and observe with light, it starts to have a bunch of mysterious properties, and to a large degree it is not fully understood yet. And probably the most amazing thing about light, well, actually there's tons of amazing things about light, but one of the mysterious things is when you really get down to it, and this is actually not just true of light, this is actually true of almost anything once you get onto a small enough quantum mechanical level, but light behaves as both a wave and a particle. And this is probably not that intuitive to you, because it's not that intuitive to me. In my life, I'm used to certain things behaving as waves, like sound waves or the waves of an ocean. And I'm used to certain things behaving like particles, like basketballs, or I don't know, my coffee cup. I'm not used to things behaving as both. And it really depends on what experiment you run and how you observe the light. So when you observe it as a particle, and this comes out of Einstein's work with the photoelectric effect, and I won't go into the details here, maybe in a future video when we start thinking about quantum mechanics, you can view light as a train of particles, of particles moving at the speed of light, which I'll talk about in a second. And we call these particles photons. If you view light in other ways, and you see it even when you see light being refracted by a prism here, it looks like it is a wave. It looks like it is a wave, and it has the properties of a wave. It has a frequency, and it has a wavelength. And like other waves, the velocity of that wave is the frequency times its wavelength. Now, even if you ignore this particle aspect of light, if you just look at the wave aspect of the light, it's still fascinating, because most waves require a medium to travel through. So for example, if I think about how sound travels through air, so let me draw a bunch of air particles right here. I'll draw a sound wave traveling through the air particles. What happens in a sound wave is you compress some of the air particles, and those compress the ones next to them. And so you have points in the air that have higher, I guess you could say, higher pressure, and points that have lower pressure. And you can plot that. So we have high pressure over here, high pressure, low pressure, high pressure, low pressure. And as these things bump into each other, and this wave essentially travels to the right, and if you were to plot that, you would see this waveform traveling to the right. But this is all predicated, or this is all based on this energy traveling through a medium. And I'm used to visualizing waves in that way. But light needs no medium. Light needs no medium. It needs no medium. Light will actually travel fastest through nothing, through a vacuum. And it'll travel at an unimaginably fast speed, 3 × 10⁸ meters per second.